Me, Yasmini, if I would say something small. Today I was with a team somewhere. We are doing some research work, and I tried the poll thing. I have this fence, and I'm doing this number of polls, and it was very exciting to just realize how many of us are not, like we take it for granted that we know the answer of some of these things, even as adults. And I used I had some sticks. So I used some sticks to demonstrate, and people were like, I wish this is the way teacher retooling is done. So for me, that was a ha moment because then just like I realized that it was a very simple like thing, but I really learned a lot. So I shared it with other people, and they were like, I wish this is the way teacher retooling is done. So it was very exciting. Thank you for the experience.
Thank you. That makes me very happy. Thank you. Thanks for sharing that. That little that. Does anyone else want to share? Subitizing in the hundreds chart, and I think it's getting better. Great. Thank you. Michelle. Anyone else? Okay, I'm going to just keep going because I know we started a bit late. So, if you remember, 2 days ago, we talked about two-digit addition and subtraction, and we were really focused on the hundreds chart, right? Using alternate strategies, trying to think what are some different ways to add and subtract two-digit numbers before you teach the column, right? The column method, which we know is something that our teachers teach often and a lot, and so we wanted to do this groundwork first. Today, let's talk a little bit more about the column. So here you see a problem, 25 plus 4. And what do you think? What mistake did the student make?
Place value?
Mm-hmm. Yes, thank you. Thank you. Can you say a bit more?
I send place value of the digit.
So what did they not understand about place value?
They don't understand, for example, that 25 has tens and ones, and
Mhm.
4 has only ones. So
Exactly.
instead of placing 4 at the right place of place value for ones, the child placed at the place value for tens.
Mm-hmm.
Yeah.
Exactly. Thank you. So this is exactly it. The child, they they don't understand this vertical column addition, right? They're having some problems with it. Anyone else want to share? What would you do if you were this child's teachers? Or what questions could you ask this student to help them understand? I see some comments. Let me see. Yes, place value, wrong alignment of digits. Yep, exactly. You guys all got it. What would you do if you were their teacher? Go back to the place value concept, then build from there. Yep, reteach place value. Good. Those are some good things to do. One very helpful tool to use is a place value chart. You know, where you just draw a chart on the board and you have tens and ones. So just how many tens, how many ones in each number. So that's kind of the foundations of place value. Yep, counters, that's a good idea. You could use these, the bundles and sticks. Show me the bundles and sticks. Yep, you can expand 25 to 20 and 5. Great ideas. Great. Okay, fantastic. Let us go to this activity. So, what I would like you to do Yep, the place value chart. Great. Here is a word problem. Fatima has 24 oranges and 13 mangoes. She wants to find out how many fruits she has in total. So let's just do just that first one. Can you all do me a favor? And what I would like you to do is use, hopefully you have enough, your bundles and your sticks to solve this problem. Pretend you are in grade 2. You're just learning about bundles and sticks and place value, all of that, and see how could you use your bundles and sticks to solve this problem.
Yasmin.
Uh-huh.
You can arrange them in form of tens and ones.
Mm-hmm.
For example, for the 24, you can fold them in form of 2 tens and 4 ones.
There you go, like this.
Yeah, 2 tens and 4 ones. And then for 13, you can have 1 10 and 3 ones. So you put all the tens together,
Okay.
and then you put all the ones together.
Oh, I'm losing my sticks. Okay. So if we do that, how many 110s do we have?
We'll have 3 tens
3 10s and how many ones?
and 7 ones.
We should have 1, 2, 3, 4, 5, 6, 7.
Yeah.
There you go. Perfect. Thank you. Can just if you have your bundles and sticks with you, would be great if everyone can just kind of try that out. Yes, Elizabeth, go ahead.
Sorry, I don't have bundles of stick, but I can do the explanation.
Okay.
I
Do you want to
I-
do the one for the subtraction?
the addition first.
Okay.
Or you wanted us to do the subtraction?
Yeah, let's do the subtraction because
Fine.
yeah, because
It is
Makara did the addition. Go ahead.
Okay.
I'll model it.
Okay, I would say that I would represent 32 oranges as 3 bundles of 10 sticks.
Okay, here you go.
3 bundles of 10 sticks. Then 2 and 2 loose ones. So I would have 2 loose sticks and 3 bundles of 10 sticks. Then I would take away 2 loose ones. I would take away 2 loose ones and 1 bundle. And I would remain with 2 bundles of 10 sticks, which is 20.
Perfect. Excellent. Thank you for that very, very clear explanation. Thank you. Anyone else want to try it? I see some people are trying it right now. Let me see. And the other way, just because we are virtual right now, this is also another way. I'm not sure if you guys can see. This is a great website that has free online manipulatives, but I can also do this, right? So if we were doing, it was 30. So these are my 10s, right? This was 32 that we just modeled. And if I am going to take away 2 ones, right? So there's 1, 2, and 1 bundle of 10. Now we have left 20. And I'll put this if anyone would like to try it. It's a great website to use, especially for virtual things. I see Bushnell is showing us the bundles and sticks. Very nice. I like your layout there. That's very nice. Great. People have their bundles and sticks. Very nice. Okay. So just to go back to this again, having students have these kind of multiple opportunities to this we would say is the start. It's not the vertical, but before you get to the vertical, you want to do, yesterday we did, or 2 days ago, we did things with the hundreds chart. Here, you want to, the next step in that is to start modeling it with bundles and sticks. So we don't want to go straight to the written algorithm. We want to model it with these types of manipulatives so that students get a sense of what it looks like. What is the process of using place value when you're adding and subtracting? So just to go over this a little bit, what do students learn as they go through this? So the first is what we just did, adding numbers up to 99 using place value materials. We could have done it using the place value chart as well, right? That can also be very helpful. So we modeled it here with the bundles and sticks. The other thing you could do, which I think is very helpful, let me see if you guys can see this, is you could do something, like this with your tens and ones. Right. So that's also very helpful to help students, line it up and sort out the different numbers. And you see the example here. Once they've done that, once they've used bundles and sticks, they know how to use them, they're doing pretty well with that, then you might want to take out the bundles and sticks and just use the chart, right? That's your next level, is you start using more of the numbers. So the problem we just did, like 32 minus 12, you might write 32 and you might write 12, right? And you might do this in the place value chart to help students kind of learn how to line up the numbers and think about them. And then your very last step is down here where you see students are just adding 21 plus 15 or 42 plus 5 vertical, right? So there's basically what we want to say is what we see in schools a lot, and I'm sure you all know this, is teachers start with this bottom row. That's the first thing they do. They just say vertical addition, go add. And that's where you see a lot of the errors that students might make, right? So if we use this progression and we start with the alternate strategies like the hundreds chart, we move to the place value chart with the bundles and sticks, then we move to the place value chart just with numbers, and then you do just the problem. That's kind of a sequence of activities that really helps children understand the algorithm. And that's where you get less of the types of errors that we saw on that first picture, right? This type of error is because you probably haven't gone through that whole sequence. So the students don't know. If you've done these bundles and sticks over and over and over, and you've done the place value chart, it's going to be really hard for a student to write the 4 in the tens place because they have all these prior experiences, right? So this type of error comes up because often teachers haven't really laid the foundations of vertical addition and subtraction. Subtraction, I won't go over in detail, but it's basically the same thing, right? Go use the place value materials, use the place value chart, and then go to just the vertical subtraction. Any questions or comments here? Nothing? Okay, I'm going to keep going. So now let's move into a problem like this, which is obviously a little bit more complex, right? 18 plus 26. What I'm going to do is I'm going to do two models for you. So I'm going to show you 18 plus 26 in two different ways. And I want you to then, I'm going to ask you, what was the difference between these two ways? So I'm going to stop sharing my screen so you all can see me. Can everyone kind of see this mostly? For the most part, yes? Good.
Yes.
Great. Thank you. So 18 plus 26. So first I'm going to model it. So good morning, class, or good evening, actually. Today we're going to solve the problem 18 plus 26. So how do we do this? Well, I write the 18 plus 26. 8 plus 6 is what, class? Anyone?
14.
Thank you. 14. So we write the 4. We carry the 1. 1 plus 1 plus 2 is 4. 44. There's our answer. Okay, so first you add the ones column, you write the number here. If it's bigger than 10, you put the number, you carry the 1, you add 1 plus 1 plus 2, and you get 4. That's the answer. Okay, so that's model number 1. Now, I'm going to do model number 2. Okay, so model number 2. Class, today we're going to add 18 plus 26. So here is 18. Can everyone get 18 bundles and sticks? Okay, so show me your 18 bundles and sticks, and I'll draw them here. Here is my 10. 1, 2, 3, 4, 6, 7, 8. Okay, so here is 18. I know has a 10 and an 8. So 10 and 8. Great, thank you. Thank you, Bushnell, for showing us. Thank you, Evelyn. Great. And now we're going to add 26. So can everyone show me 26? Okay, I see 18. I almost see 26. Great. So we have 18 and 26, 2 10s, and how many ones?
6.
6
Thank
ones.
you. 6 ones. Okay, now let's add first the ones. Okay, so put all your ones together. Let's put all of our ones together in a group. And how many do we have if we put all the ones together?
14.
We have 14, right? We had done that before. Yes, thank you. We have 14 ones.
14.
14, thank you. We put them together. Now, there's something here with this 14. What can we do with this 14? We can
have it as 1/10 for ones.
exactly. We can make a group of 10. So take your 14 ones and make a new bundle. So I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to make a new bundle here. Right there. Right? And I have 4 ones left over. So I can write the 4 there because I only have 4 ones. And this 10, right? It's not a 1, it's a 10. This 10 moves over to the tens column. So I can write it up here in the tens column. And now, how many tens do we have? We have 1, 2, 3, 4. Yep, go ahead.
Mhm.
Go ahead.
4 ones, 4 tens.
4 tens or 40, right? We could count this here as 10, 20, 30, 40. And we can put a 4 there because we know it's in the tens columns and we have 44. Okay? So,
Okay, yes.
can someone tell me what was the difference between those two models? The first one versus the second one.
Well,
Go
I think
ahead. Oh, thank you. Or Bushnell, if you want to go. Either one.
yeah, I was saying I think the first model
Mhm.
to me appeared so technical, but the second one was a bit practical. The child is likely to remember for long what he did in the second one than the first one. Thank you.
Thank you. Elizabeth, go ahead.
I would take the second model to be at the introduction, because if a learner can be able to do the second model, then as a teacher, I wouldn't go back to the second model. So
Yeah.
to me, the second model would be my introduction, so that in fact, I wouldn't even add the regrouped one that you've put there, because already they can see, they can literally count and see there are 4 of them. But then
Yes.
I would, I mean, the 4 tens, I wouldn't
Oh,
add.
yeah.
You see the one that you've added on top of the first one?
Yeah, right here.
Yes,
Yeah.
I wouldn't even do that, because already this one, they are doing it practically, they can be able to see. But then quickly after they've understood that, to get them from the concrete now to the abstract, now I would go to the second method. Thank you.
Yes. Thank you. Great. Yeah, you guys all got it exactly. This is how you would introduce the algorithm, right? This is and again, this is that in-between step where you're trying to show them how to do it this way, but you're also trying to explain what does it mean? Like why do you move things over? What do these numbers actually mean? That's what these types of manipulatives can really help. And I think all of you picked up on that. One of the things we see so often, and this has been my experience, and please let me know if you have seen this, but what I see teachers do often is just go to the first model, and that's all they ever do. They don't ever do something like this. Would anyone else say that's true? I got a thumbs up. Anyone else want to share? So yes, that's really what we want teachers to do, is at least introduce it this way, because this is how you get a little bit more, you get students to really understand what they're doing. What we don't want is for students to just memorize, add this column, add this column. I think one of the biggest things I see teachers doing is when they first introduce this, saying 1 + 2 + 1 is 4. Because that's confusing. Think about if you are a second grader or a first grader and you hear 1 + 1 + 2. And you're like, wait, but it's actually 10 + 10 + 20, right? There's so many ways students misinterpret this algorithm. So it's really, really important that teachers explain and use the correct language. Okay, great. I'm going to keep on going unless people have more questions. Oh, Joy, go ahead.
Thank you, Yasmin. I'm just wondering, after the teacher moves the learners from the physical manipulatives, when do the children need to draw the algorithm for them to do the addition? Like, could they draw the yes, those diagrams in their books for them to be able to do the counting?
Yeah, I think that's great because that's taking our concrete pictorial abstract trajectory. So you start with the concrete, you move to the pictorial, which is what I did here, and then you get to the abstract, right? But I think yes, if you can help children, these are not perfect, so I wouldn't start with something like this because for some children it might be confusing. Like I did this, I wouldn't do this in front of a child. I would actually draw 10 in a row so it was clear that you could see 10. But yes, I think making that connection between the concrete, the pictorial, the abstract is really important. Thank you. And just speaking of, so here's just some examples of two-digit addition with regrouping. So when you first start regrouping with the vertical algorithm, use materials. This is what we just did, right? Count out the sticks, put them, you can use a place value chart to help you. That often helps students. Use the place value chart, count out the sticks and bundles, and model the procedure. Then you move to this, which is basically what Joy, you were saying, is you move to the support of the chart, support of maybe drawing these types of, whether it's this, or here they just use sticks and dots, whatever you end up using, you move to the pictorial, and then finally you get to this, add with regrouping using the standard algorithm. And again, so many teachers go straight to this last line. And you can see this procedure, what we did here, if you think about it from a child's point of view, it's actually pretty complex, right? So many ways you can misinterpret what's happening here if you don't have a really thorough understanding. And just to go over subtraction, we didn't do a subtraction, but the process is the same. It's a little bit different in the sense that if you have, let me show you guys here. If we were to do, if we were to do a subtraction, or actually I'll use the bundle sticks. What you have to do is you sometimes have to take, if you have, let's say I have 12 and I want to take away 4. Well, I don't have 4 here, right? So you have to actually undo your bundle, take apart your bundle, and then you can take 4 away, and then you have some left. And that unbundling, like, oh, I have a group of 10s, I have to take it apart. That is so important for students to understand, that physical process of breaking apart a group of 10, right? So I think the more that you can do that with the kids, the better. Okay, I'm going to keep on going unless there's, let's see, where are we? We're on overview. Any other questions before we try this ourselves? Okay. So you have an activity in the Google Drive. If somebody could put a link to it, that would be great. This is the regrouping activity. And basically what you're going to do, I know it's very small here, so it's really hard to see, but what I want you to do is to practice some of this progression. So whether you want to do it with the bundles and sticks, or you want to do it with the place value chart and draw it on the board, you're welcome to use that website I sent, the virtual manipulatives, to show the screen and to show what students are doing, all of that. Oh, thank you. Thank you, Bushnell, for the Google Drive. And again, here is the link to the virtual manipulatives. If you want to use them, you can use them just to help model with your friends. But let's take about 15 minutes, and I would love for for everyone to be able to just try it out, practice. What does it feel like to explain an addition or a subtraction using the place value materials? Takes a while to get used to. Okay, so I think we can go ahead and go to breakout rooms. Walter, could you make me a host again so I can go between the groups? Or anyone? Actually, let's do 12 minutes if possible.
I think it's Caitlin working on the groups.
Oh, okay. Caitlin, could you make me a host if possible? Oh, Caitlin, could you make me a host? Is there any way you could before I join?
Yes, we can please. I hope you
Oh.
can. Yeah.
Yes, thank you. Let me make you a co-host though, because I don't need to be the only host. Just see. Are you a co-host now? Huh, why won't it let me make you a co-host? Oh yeah, there we go. Okay. Now we can both be the host. Thank you.
How many groups have we opened? I see some people are here, some people are not there.
There's 5 rooms.
So we're supposed to be like 4, and I can see here we are 10. If there are 5 rooms, we're supposed to be like 5 people or thereabouts.
Yeah, I think people, it says they're all assigned. They just haven't joined yet. So maybe they haven't. Do you all see the little button that says join? Like Alex, you should be in room 5. Charles Kimaru, room 5. Elizabeth, you should be in room 4. Lydia, were you able to get into a room? You should be in room 3.
I said join, but I don't know. That is the time you were changing over with
Oh,
Caitlin. So it I clicked on join, but it did go okay. Now it's yeah.
did that work? I'm not sure why some people still aren't in their rooms, but guess we'll figure it out. Oh, there we go. Okay, welcome back, everyone. I think everyone had a chance to try it out. I went to some of the groups. Did everyone have a chance to at least try out the process and what it feels like? I hope. We don't have a very talkative group today. Thank you. Okay.
My voice is not clear.
Okay. Is there a question?
Yes.
Did you have a question? Sorry, I didn't catch the whole question.
Sorry, I thought I
Did
was
you
in
talk?
the group.
Oh, okay. Yeah, no, now we're back. But if you have anything to share, does anyone want to share a thought about how it went in your group? It's okay, Lucy. Thank you.
Well, maybe I could say something, Yasmin.
Yes, thank you.
Well, in our group, we had a chance to look at the problem in the Google Drive, and we were adding 29 chicken and 14 goats. So we went through that process of identifying the tens and the ones, and we got the 2 tens and the 9 ones representing the chicken. Then we went to the goat. We looked for, we got 1 10 and 4 ones. And now we showed the learners the process of now bringing them together. If it is a 10, take it to where the tens are. So we have 2 tens, and on this other side we have 1 10. Take this 1 10 and put it together with the 2 tens. And then we have 9 ones and we have 4 ones. Let's now put all together, the ones together. Now, once we put them together, again, we want to find out how many are they. We found out that they were 13. Now, from this 13, how many tens are there? So we took the students or the learners through the process of now counting and identifying that in 13 we have 1 10 and 3 ones. So we helped the learners to bundle the 1 10 and now ask them, where do you think this 1 10 should be taken? The learners said this 1 10 should be taken to the tens place. So remember, we are introducing the place value. So we said, let us take this 1 10 to the place of the tens. So we put it there. And then let's take this remaining 3 ones to the place of the ones. And then we finally ask, how many tens do we now have? How many groups of 10? And how many ones do we have? You know, that is where there is always an issue, connecting, and even, the language. They need now to see, connect the idea, and then be able to interpret the language. That now we have 4 tens, and 4 tens is what we call 40. And we have the 3 ones, and this one now are ones. So the 4 tens, these are 40. We put them together with 3, so we have 43. And I think this one needs to be done for a number of times until it sinks in the learners, so that immediately they just see 4 groups of tens, and then they see maybe 6 ones. Using the method of subitizing, they'll be very quick to say, that is 42, that is 43, that is 44. So that is what we did in our group, and I think it was a success. And I'm just looking forward to the kind of an experience we'll have with the learners in the class next year. Over to you, Yasmin. Thank you.
Thank you. Thank you. Very eloquent. Thank you for sharing. Virginia?
Yeah, thank you. Thank you, Yasmin, and thank you, Bushnell, for sharing. We managed to do 2 rounds of the first item with the numbers given, and the other presenter did a different set of numbers just to bring out the difference. Of course, the process was similar to what Bushnell has explained, but one of the areas we were reflecting around was Sometimes bundles and sticks can be very messy, especially when you are manipulating large numbers. So one of the items, you say, is if something is adding up to 90 or 90 something or 70s, in the ranges of 60, 70, 80, 90s, those would be so many bundles. And when I think about a typical classroom in Bungoma here, those will be like 8,000 sticks, or rather so many sticks in one class. So we were reflecting around what have we found works in terms of if you were to place a limit on the ceiling or the maximum sum that we can use for sums involving bundles and sticks, because in the spirit, Yasmin, of moving from concrete to semi-concrete, we also have other methods that could be more efficient, like paper money, or someone wanted to demonstrate to us was it the place value chart or something. So what has been the experiences just to be able to contain this orderliness and some bit of sanity in the classroom?
That's a good question. Does anyone want to try to answer it that has experiences? I like the idea of, I think if you have limited materials, you're trying to contain the orderliness. Having the students solve problems using the bundles and sticks, like, 13 plus 8, right? Keep the numbers in the lower range so that you're not, like, it's very hard to use bundles and sticks to add 64 plus 32, right? At that point, you probably don't want to use, either you don't want to use physical bundles and sticks, or you want to move to the pictorial. So I like the idea of bounding it with the lower numbers and saying we use the bundles and sticks with the lower numbers. The other thing they could do is if each student has about 30 sticks or 20 sticks or something, they could work in groups of 3, right? So they pool theirs together and each student does it together or something like that. That's what I've seen before. And, trying to stay below 30 or trying to stay below 40 or something like that. So that's one possibility. I think, I have seen place value material when people don't have bundles and sticks, where they say things like, let's say this pink marker are 10s and these are 1s. And I would suggest we don't do that in the very beginning. Maybe eventually you can, but I wouldn't do something like this in the beginning, because there's nothing 10 about this, right? I think that's confusing for a child because it's not 10. So you're giving it an artificial value, and I think that makes it more confusing for children. So I would stick with the bundles and sticks. And, worst case scenario, you don't have bundles and sticks, you can draw them, right? The students can draw bundles and sticks. It's not ideal, but it's better than not using anything, I think. Okay, I think we're to move on. We're gonna take a break in just 5 minutes, but I wanted to do just another quick round of this one, which is building mathematical knowledge. We talked about this last time, about, what is it, the mathematical content, how to teach it, and how children learn best. And I'm going to give you all a question that I'd like you to try to find the answer to. So a teacher looks through students' homework and finds errors in these 3 examples. The question is, which have the same kind of mistake? So I see lots of people are saying C, 1 and 3. Any other answers? Any A's or B's? Lots of C's. So someone that picked a C, can you tell us why?
I'll tell you why I think C is the same kind of mistake.
Okay.
In both 1 and 3, I think the student counted the ones and then carried forward 1 instead of 2 for both cases.
Okay, good. Everyone agree? Does anyone have any questions for him?
I think it is in all.
You think it's what? Sorry, say it again.
The mistakes, were they not similar across all?
Well, so in 1 and 3, the error was, as we heard, was they added the ones and then carried over a 1, but it should have been a 2. What's the error in number 2?
Addition of ones.
So say more.
Okay.
Go ahead.
Addition of ones is wrong.
In what
Wrong
way?
addition. 2 plus, yeah.
Go ahead. Sorry.
Gillian, come again.
Number 2 is different from 1 and 3 because 1 and 3, the addition of 1 could be correct, of which we don't know. But for 2, addition of ones column is wrong because we should be having a 2, not a 1. Then carry 1.
Yes.
Then addition of the tens is correct, even after the carrying over 1, which is also correct. In case the learner had got 11 after addition of ones. But in 1 and 3, the carrying, instead of a 2, they carried a 1. Thank you.
Thank you. Thank you. Thanks for that explanation. That's very, very clear. Go ahead, Virginia. Question?
I think my bigger challenge with this child is they don't know what to carry. So across all the 3 items, I would still feel they made the same mistakes because they are used to always carrying 1. So that's actually so item 2 may have 2 problems in 1.
Yeah.
That there was wrong counting plus wrong carryover or wrong, the wrong regrouping. But if you think in principle, when you're even assessing this from a place value perspective, I would say there's a common mistake across the three items. The child hasn't mastered what to carry, and that's why in item 2, because there is always this song they sing in class, carry one. So
yeah. But let's look at number 2. Did they carry over the right number?
Yeah, they did.
It's correct.
It's correct, right? Because it's 12. So they carried over the right number. So what you don't know with child number 2 plus 3 plus 7 and miscounted, 7 plus 3 is 10 and 2 more is 12. Maybe they counted on their fingers. Maybe they messed up something and they thought it was 11. So I might look at number 2 and say, well, this child, they understand that they may understand that they know how to carry, right? I get 11. If the answer was 11, they carried the right way. right? You put a 1 on top, you move over the 10, and then you write a 1. So they might have understood that. They might have just made a counting error. So it's worthwhile asking this student, hey, can you just look at this again, right? Students make counting and adding errors all the time, even up until 4th and 5th grade. It's very common, and it's not a big deal. That's why you tell the child, hey, go back and check, right? Go check your answer and see if you did it correct. But now in problems 1 and 3, what I see is the child added the numbers correctly, right? They know 9 plus 7 plus 9. They probably were able to get 25. The problem I see there is what you all were saying with the place value. They just carried a 1 because, as you said, Virginia, students just learn, oh, you just always put a 1. You always, no matter what you're doing, you just put a 1 up there. So that to me is a bigger problem, a place value issue. They don't understand something about vertical addition, right? But child number 2, we don't really know, but it looks like, to me at least, that child number 2 just probably added wrong because they did carry correctly. You know, you could give them a problem like number 3 to check, right? You would have to do some additional checking to see, well, here's problem number 3. Do they also carry a 1 or do they get it correct? So these are just, you know, it's a very small nuance. It's a very small difference, but there is something different in the types of errors that these students are making, right? There's something a little bit different. Okay, let me just go to one more quickly. Okay, here's one last one, and then we'll take a break. This one's an easy one, I think. I see some C's coming out. Okay, in the interest of time, can someone explain their answer and talk us through it? Thank you. Go ahead.
Okay. It is me. Um, this learner added 36 and 35 plus 36 to get 11 ones and 6 tens. So he doesn't know the regrouping or carrying. So the teacher should revisit the place value of numbers so that when the learner gets 11 on the column of the place value, on the column of ones, he can be able to break it down into 1 tens and 1 ones. Then carry over the 1 tens to the tens column and then add to get 7. Thank you.
Thank you. Very clear explanation. Very, very clear. Thank you. Exactly. That we can obviously see what the child did wrong. They didn't regroup. They didn't carry over, and the teacher should review place value. Maybe they should use, you know, bundles and sticks or something like that. Elizabeth?
Thank you. Is it also possible that the learner added from the left?
Very possible that they started with 3 plus 3.
Then 6
Yep.
plus 5, 11.
Yep, exactly. That's another very, very good possibility, in which case, again, looking at place value would help, right? To think about, why do we add the ones first? what's the significance of that? Instead of it just being a rule to follow, why do we add the ones first? So just to say these types of problems, again, if you can engage teachers in this type of problem and talking about all of this it's great. It's great to get teachers thinking and thinking about analyzing student work, right? Because we don't do that very often, but we want teachers to look at what students are doing, think about it, and then, if possible, address it. I know that's a very hard thing to do, but this is kind of the first step. So let's, there's supposed to be a break here. Let's take a 5-minute break and then we'll come back and we'll finish up with geometry and spatial sense. Thanks, everyone. Hello, everyone. I don't know if everyone is back.
You're back.
You're back. Thank you. Thanks, Walter. Okay, let's go ahead and get started. Thank you again for sticking with me for this last hour. I know this is a rough time for you all, so thank you. Let's talk about geometry and spatial sense. This is like one of the funnest topics, I think, to talk about. So we're gonna have fun looking at shapes. Here we go. Okay, let's start with our illustration of teaching. What is this shape? And the child says a square. What mistake did the student make? Anyone want to share? Maybe someone new that hasn't shared yet today. Or someone that has already shared. I'll take anyone that wants to share.
Me.
Yes, go ahead.
And the mistake the lad made is mistaking a square with a rectangle, confusing the two shapes.
He's confusing the two shapes. Which shapes are they confusing?
Square with rectangle.
Exactly. A square and a rectangle, right? Very common mistake in the early years. What would you do? What question, if you were the teacher here, what's a question you might ask the student to help them?
And asking the types of shapes they know before I introduce the rectangle or the square.
Say that again. Sorry, you cut out for a minute.
Okay, I was saying, and asking the names of the shapes they know before I introduce the concept of rectangle and square.
Okay.
So I
Yep.
get to know what they know and how it looks like.
Okay, great. Thank you. Oh, great. Someone has their hand raised. Go ahead.
Hello, this is Simon.
Hi,
Maybe
Simon.
I will ask the learner maybe the items or object that have that shape, maybe like a door.
Okay. Okay, so to find other objects. Okay, great. Thank you, Simon. Walter?
Yeah, I think the challenge might be the mistake. The student think that all four-sided shapes are squares, and might not understand the concept of the different shapes. I think the challenge would be that they think that all sides are equals. Some could be the challenges of vocabulary, not knowing what the difference between a square and a rectangle is in terms of that. What I could do to help the student is maybe like ask the student what they notice about the different shapes and the sizes of the shape between a square and a rectangle, and maybe also compare what the length that they have.
Okay, great. Thank you, Walter. Thanks. And I see lots of great answers also in the chat. And I think you guys have all got it exactly. What you want to do as a teacher here is go to what we call the attributes of a shape, right? So look at it and ask the student, okay, well, how many sides are there, right? And I think someone said this, well, there's 4 sides. Oh, go ahead, Virginia.
Yeah, Yasmin, I wanted to push it a little bit back to I think this asking of what mistake the child made and why.
Yeah.
Could we ask how did the teacher teach this concept at the beginning before they ask? Because I think that the responsibility I would, especially for such a case, I think this teacher just came to class, drew a number of shapes one morning, and told the children, these are square, these are rectangle.
Sure.
And in the spirit of the CPA continuum, where you have to gradually build the mastery around the concrete pictorial abstract. I think for me, I'm finding it powerful these days to reflect from a point of how do you think this thing was taught that leads to this kind of understanding for the child. But yeah, I agree with the contributions and the observations of the team.
Great, thank you. Yeah, I agree. It's not, any mistake a child makes, and we call it a mistake in math, we often call it a misconception. It is. It's on the teacher, I think. We need the teacher to be the one that's, introducing all of that. I think the one thing I would say is that also we know that misconceptions they're a very normal part of mathematics instruction. We actually want children, as I said before, to make errors because that's what helps the teacher and that's what pushes further understanding. And if you think about like all of you, if you are you're learning something, when you make a mistake and you learn from your mistake, that's actually how you learn, right? That's a big part of learning is making a mistake, doing something the wrong way, and then figuring out how to do it correctly. Right. And this could be applied to anything, to reading, to writing, to like building furniture, like you build furniture and you do it the wrong way and you realize, oh, wait, I did this wrong, and you learn from that mistake. So I think partially it's yes, that the teacher owns it more, but even if you have the best teacher in the world, the student is still going to make errors. And that's good. We want the student to make some errors because that's part of the learning process. Oh, great. Thank you. Thanks, Virginia. Can you send out that link about the misconceptions? That would be great, I think, for people to look at it. Okay, let's go ahead and keep going. So what we're going to do is talk a little bit about 2D shapes. So I would ask you guys, I hope some of you have paper, pencil, and scissors to cut out a square, a rectangle, a circle, and a triangle. If not, I'm going to just share my screen and I'm going to ask you, let's pretend you all are students. So I'd like you guys to all be students right now in, let's say, grade 1. And can you see this? If you have those shapes, it would be great. You can also use this website because, again, it has, oops, you have to go up to geometry and you have all these great shapes. So I'm going to put this shape right here. How do I make it bigger? Okay, let's just go with this. So here are some common shapes that I'm just going to put out here. Okay. I'll just change these colors so they look a little different. Okay. Let's talk about these shapes. So let's talk about a triangle. How many sides do you see on a triangle? Can somebody tell me?
Yeah, three.
Three sides, right? 1, 2, 3. What about a circle? Do you see any side? How many sides are on a circle? How many sides are on the circle?
I see
Teacher,
I
one.
will say
which is the circle?
How many sides? Sorry, I heard some people talk, but I couldn't quite hear.
Uncountable. Uncountable number of sides.
Uncountable. That's
Very
yes,
many.
infinite is the correct. It's
Infinite.
the correct. For a young child, you might just say, we don't see any sides, right? We can't see any of them right here. Can somebody talk to me about what do you see as the difference? Can you explain to me how is a triangle and a square, how are they similar and how are they different? Who could talk to me about that? What's the same about a triangle and a square?
Okay, the similarity is that they are all closed shapes.
They're all closed. Yep, exactly. They're all closed shapes. Okay. And what else is similar about them?
They both have straight edges.
They both have straight edges. Yes.
Sides.
Perfect. Great. And now what's different? What's different about them?
The square has more lines than or more sides than the triangle.
Yes, the square. Let's count the square sides. 1, 2, 3, 4. Square has 4 sides. And how many does the triangle have? 1,
Right.
2, 3. Exactly. 3. Right? So the triangle has 3 sides, the square has 4 sides. What about, you could do a square and a rectangle. What's the same about the square and the rectangle?
The number of sides is the same.
Number of sides are the same. What about these things right here on the edge? We have corners or vertices, whatever you choose to call it at this point in time. How many corners or vertices are on the triangle?
4.
On the triangle?
Triangle, there are 3.
3. On the rectangle?
There are 4.
And on the square?
There are 4 also.
4. Right. So these are just the kinds of conversations you want to have with students, right? We don't want to just say, this is a triangle, this is a square, this is a rectangle. But really getting students to pay attention to the features is actually really important. So it has 4 sides. It has 4 corners or vertices. The 2 sides on a rectangle, on a rectangle, 2 of the sides are long and 2 of the sides are short, and they're the same. Or getting students to observe and think about shapes is actually really important to build up their knowledge and vocabulary. It's not just about knowing the name, it's about knowing the features and being able to talk about different types of features and compare and contrast them. Okay, so let's go back to this. And apologies, it's a little bit hard to monitor the chat at the same time. So thank you for participating via the chat. I do appreciate it. Let's move on to
Let
think
me know
about.
when you want me to assist, Yasmin.
Oh, okay.
To just help you as you breathe.
That would be great. So if people respond in the chat, maybe you can just bring it up for the whole group.
All right.
Or have comments. That would be great. Thanks, Virginia. Let's talk about 2D shapes and what children learn about 2-dimensional shapes. So they flexibly sort 2-dimensional shapes according to properties, right? So you might just say, even before you tell them the names of the shape, you might give them a whole bunch of different shapes and say, let's put all the shapes with 3 sides over here, and all the shapes with 4 sides over here, and all the shapes with 5 sides in a group. So they learn how to sort them. You could even say, let's put all the shapes with sides or shapes where we don't see sides, right? You could do different types of things. Then you start naming them, right? Obviously, this is a rectangle. This is a triangle. So there's different ways to name them. You might ask also a very good activity for young children is to draw the shapes, right? You can use a ruler or whatever you might have to make straight lines, but you can ask children, draw a rectangle, draw a triangle, draw a circle. Those are good. You also then you get to describing the properties, which is what we talked about. How do you know this is a square? And getting children to tell you. And there's a lot of language in geometry, right, that you want children to use. So obviously, if you can use you know, a mother tongue, that's great. A language that the student understands to talk about. How do you know what this is? Talking about it, describing it is really important. Comparing, which is what we just did. And then, you know, eventually at some point, you also want to talk about lines of symmetry. So like taking a shape, folding it in half and saying this side is the same as the other side. That maybe is more about grade 2, grade 3, when you start thinking about symmetry. Okay. There's no questions. I'm going to keep going. Oh, that was 2D shapes. Any questions about 2D before we cover quickly 3D shapes? Okay. 3D shapes. Can everyone just look around where they are and try to find a cuboid or a cube? I'm not sure. Do you call them cuboids or cubes in Kenya? Whatever you call it. Try to find one in your environment. You have both. Okay. I call it a cube, but try to find a cube somewhere in your environment. Does anyone have one that they can show us? Nobody wants to show us a cuboid?
Can't find anything in my environment. The only thing that exists is a switch that is fixed on the wall.
Okay, that's fine. Remember, a cuboid can be in what I would say when I say cuboid is I also think about rectangular prisms. That's another word for it. But they're all around. Like if anyone has a window. Oh, there you go. Thank you, Walter. Can you show that again? What is it? Okay.
Letterbox.
Yep, that's a cuboid. Perfect. Anyone else? A door? Anyone has a door? A window? This right here is right, because it's a little bit thick, so this is a rectangular prism, more or less. Anyone else have anything they want to share? Or can show us? Oh, thank you, Evelyn. Yep, that's like a box something. Yep, that's a cuboid. They're all around us, right? There should be cuboids everywhere. Now see if you can find something that is almost a cuboid, but not quite. So look around and see, okay, what is something that I might say is almost a cuboid, but is not? And why? Yep. Walter, can you share can you tell us why it's not a cuboid? Yep,
I
thank
think
you, Pete.
because of this extension that is here, So if it was just this place to this one, then it would have been, but the extension that is here now makes it different.
Yeah, exactly. No, that's a great point, right? The extension, it's like you have a couple of different objects put together, right? Elizabeth, let me see. You had something, but I didn't see it. Yep, that's a cuboid. Great. Great, Eric. Let's see. Oh, yeah.
Can you see mine?
No.
Can you see mine?
Yes, Eric, I see is that your phone?
Yeah, exactly.
So is that a cuboid or is that almost a cuboid?
Almost a cuboid.
Why almost?
Because at the can we call it the corner vertex? Actually, it's curved, meaning now it is not sharp. There are.
Yep. Oh yeah, I see, Juliana. I see yours. Nice. Yep, exactly. Right. We often see like here's my phone, but if you look at it, it doesn't have corners, right? Where two lines meet. Doesn't have corners. It's still mostly a cuboid, almost, but not exactly. I see, Peter, you've got some. Do you have one that's almost a cuboid? Bushnell? All right, let me stop sharing.
I think this one was almost a cuboid, this one.
Okay.
But then we have this. To me, I think this side is too long. This one.
Okay.
And this is a shorter. The length here is short, so this is what makes it now not to be a cuboid.
Okay.
I think if the distance was the same, then I would have said it's a cuboid, but it is almost.
It's not quite exact.
Yeah.
Okay, great. Okay, let's go back to this. So again, just thinking about, a lot with 3D shapes can happen just in your environment because our whole world is composed of 3D shapes. So what do children learn about 3D shapes? It's similar to what you do with 2D shapes. You learn to flexibly sort the shapes according to properties. You identify them, you describe the properties. So again, how do you know that this is a cuboid? And what we just did, talking about, well, it has four sides, or it has four corners, or not four, it actually can have any more. With 3D shapes, we talk about faces, right? Faces and edges is kind of the language that you use a little bit more with the 3D shapes, and then you compare them. So very similar types of trajectories with 2D shapes and 3D shapes. So now we're going to move to spatial sense. I don't know if anyone does anyone have any questions about 2 and 3D shapes before we move to spatial sense?
Yeah, there was a question on the chat, Yasmin.
Okay.
From Makoba, Izito. He's asking, if a child says a triangle has 5 sides, what is wrong with that, especially while using 2D shaped triangle? And he has an image inserted there on the chart.
Okay. Good question. Does somebody want to tackle that? Does somebody want to try to answer that? If a child says a triangle has 5 sides. Excuse me. Oh yeah, cuboid and cube. Thank you for the difference. So you use both. Anyone want to answer that question about what is a child? Is it wrong if a child says a triangle has 5 sides? Nobody? I'm sure somebody can answer that. What would you do if a child said a triangle had 5 sides? Sides are not equal. All right. Did anyone say something here? No. Oh, go ahead.
Can I
Thank you.
be heard? Good evening.
Yes. Go ahead.
Thank you so much. My environment not so good, but from the naming, try means 3. So as they are naming the shapes, maybe when they come to other attributes of those shapes, a try means 3. So if a child says a triangle has 5 sides, that is not right. So we will go slowly and teach them that now 5 sides adopts a different name with the penta. But now that will be at a higher level. Thank you.
Yes. Thank you so much. And Osumba, do you want to share something? No? Okay, we'll keep going with spatial sense. So I do want you guys to try to do this. Spatial sense is really important. What is spatial sense? It's basically the idea of composing and decomposing shapes, manipulating shapes, and locating and describing objects in space. So being able to say, the book is on top of the table. The pencil is underneath the book, or the dog is under the desk, right? There are all types of things. So describing objects and then composing and decomposing shapes is actually a very important activity where we really want students to be able to see how you can take a shape and put it together and break it apart. So very similar to what we do in number, right? In number, we do a lot of composing and decomposing of number. We do the same with shapes. We want children to have experiences, and this is often something that's not included in a lot of curriculums, but it's really important. So I would ask you once again to go to either this Polypad Amplify if you are able to, or if you have, I like to do sticky note triangles. So if you have, just a pad of these kind of sticky notes, you can take them and you can just fold them like this to make triangles. So if everyone can just get some triangles and make a few triangles. If you don't have sticky notes or you don't have if you can't get to that website, you can go ahead and just cut out some triangles from a piece of paper. But use it and try to then, what can you make? Look, like I can make from 2 triangles, I can make a square. If I add this, I can make this shape. I can make a house. Right? What can you make? Just play around with it. Thank you for those of you that have those materials. And just start making some triangles and see what you can make. You can also use this website. Oh, I like the different colors. Send you this website again, just so you have it. Okay, I see you made a square. Can anyone make a star out of just triangles? Violet, that's a good question. We'll answer it in just a minute. Once we're done with this, we'll talk about squares and rectangles and how to differentiate. I see some good shapes being made with triangles, with squares, with rectangles.
And as that happens, Yasmin, someone is saying they are still struggling with how they can reinforce learners' ability to differentiate between a square and a rectangle.
Yeah. Yeah, no, it's a good question. What I would say is, what we all know is that a square is a rectangle, right? All rectangles are not squares, but all squares are rectangles, right? Because if you think about the definition of a rectangle is we have four straight sides and four vertices, four corners, and a square matches that. So a square it's a special type of rectangle where all the four sides are equal. For me, getting into those types of details, like is a rectangle a square, is a square a rectangle, all of those it's more content. I've seen it being taught, and I've taught it before, like around 4th grade, 5th grade. Like I wouldn't try to do that in the early grades. The hierarchy of different shapes, and especially once you get to, some of these types of shapes and hexagons and all of those, I think just get too detailed too much for young children. So for grades 1 to 3, I would just say, a square has all four sides are equal, and a rectangle, they're not. But thinking about, is a rectangle a square, is a square a rectangle, how do you differentiate it? I think I would just stick with the all four sides are equal versus they're not. And students may make some mistakes on it, but they're not quite ready at that point to really talk about the deep differences between them. So I would just save that for a later grade. And I would just talk about equal sides versus not. And again, like whenever you're using rectangles and squares in the early grades, I would make sure they're dramatically different, right? Like a rectangle looks very much like a rectangle and a square looks like a square. And if there's any nuance in between it, I wouldn't get into measuring sides and doing all of that, if that makes sense, Violet. Okay, did everyone make some different shapes Anyone want to share their shapes? Oh, I see a star. Very nice. Oh, but you have some overlapping there with yours, Peter, but I think that's okay. I'll accept it. It's okay. Anyway, all different kinds of shapes you can make. And you could also, you know, as adults, I could ask you guys, this shape right here, how many sides does it have? Can anyone tell me? How many sides does this triangle shape have that I made? Assuming that they're all kind of touching. Anyone? Violet, you said 10? Do you want to explain? Or Joy or whoever?
Yeah, if we move at the bottom, that's one side. The
One.
long side, that's one. Then we move up the side, that's two. Then up 3. Then 4. Up 5. Then across 6. Then down 7. Then 8, 9, down, and 10.
Good. A 10-sided shape. Anyone know what it's called? What would you call a 10-sided shape? Anyone know the terminology? Juliana?
It's called a decagon.
Exactly. The decagon.
Mhm.
Right. Not something you would do with the young children, but just for us, it's nice to know all these shapes have names. Decagon, hexagon, pentagon. Does anyone know what this is? Actually just kind of fun. So if I did this, how many sides now?
I think you've added 2 more sides.
Yep. Well, I have, but I also broke up this side. So in total, we have how many sides?
12.
Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I forgot where I started from. Hold on. Let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 sides. Anyone know the name of a 13-sided figure? I have no idea. I'd have to look it up. But if anyone knows, what do we call a figure with 13, a shape with 13 sides? Anyone? Now I want to know what it's called. 13-sided shape. Whoa. This is what it's called. A tridecagon. Who knew? Tridecagon. Okay, anyway, let's go back. Yep, tridecagon. Thank you, Elizabeth. Let's go back to this. So we made some triangles. Let's talk about spatial sense quickly, what students learn, composing shapes. So again, it's really important that they do this type of activity, right? They take 2 shapes, they put them together. I made a square. They could even make, I made a house. So using shapes, playing with shapes, right? Saying, here are some shapes, draw anything you want, make a sun in a house, or put shapes together to make bigger shapes. That's something that is really important to do. The other thing you can do is give students a shape like this and say, can you use these other shapes to make it fit, right? So build a shape using smaller shapes. Decomposing is taking a larger shape, like something like this, and saying, how can we break it down? How can we cut it into different parts? And you can see this type of, it's almost like playing with shapes is really important, because as you go up in geometry, once you start having to calculate perimeter and area and all those types of things, these are the foundations that will help you, right? These are the foundations students need to do well with area, perimeter, all those concepts that are much more difficult. Rotated shapes, I think that is something that's really important, understanding that, this is a triangle right here, but so is this, and so is this, and so is this. And one thing I would say for all of you when you're doing especially triangles, don't always use the same type of triangle. We don't have to name the types of triangles, but use right triangles, use equilateral, use scalene, use isosceles, use all the different types so that students know a triangle has 3 sides and 3 corners, but it doesn't always look the same. It can look very different. It's still a triangle. So I think that's really important, because often this is the only triangle you see, right? Is just the equilateral triangle, and that's it. And then the last one, describe the relative position of shapes and objects, right? So we talked about this before. The triangle is next to the square is near the triangle. All of these types of language is really important for, thinking about where does this go in math? You get to the coordinate plane, you get to graphing points on axes, all of those types of things. This is the foundation. So you can see it. This foundation is so important for some of those later mathematical concepts, which is why we really want to build that foundation in the early grades. Okay, so there's another activity called composing shapes, and there are some handout activities. And I know we're almost out of time, but if we can just take 10 minutes right now and I know it'll be really quick, so maybe you can't teach the activity, but what I would love for people to do is take 10 minutes in your small groups to just play around with composing shapes. Ask people. The handout I gave you has an extra page with cutouts. So you can cut some of these out and you can show something like this and say, how can you build this shape? So like I can build this shape, let's see, like this, right? So I built the shape. So just try to play around with it, see how it goes. Just take 10 minutes and then we'll come back and wrap up. Thanks, everyone. Tridecagon. Ooh.
So just a group for 10 minutes, right?
Yeah, just 10 minutes.
Okay.
Very quick.
Sorry. Sorry, my laptop is hanging a little bit, but I'm trying to set it.
I think I can do it if you want. Do you want me to do it? Oh, there you go.
Special 2. We are waiting to hear from